first, a safety message. We're in a desert and we're at 7,000 feet. That means you need to drink a little bit more water than usual. If you're having headaches, if you're having muscle cramps, water is a great solution. Even if you're just a little bit crankier than usual. Water, great way to go. Look at your travel mates. Let them know. Yeah, water, you lose a lot more than you think you do out here. All right, so this might seem a little bit off topic, but I promise I have a point. How many of you, especially our junior rangers, have had or have a really, really great teacher? Yeah? Have you? You don't have a teacher? Very nice. Who was your favorite teacher? Miss Geary? Miss Geary, a first grade teacher. Gary. Yeah. I had a favorite teacher, and his name was Dr. Personette. He was my high school chemistry teacher. Chemistry. Cool. But what he did was he tied what we loved into chemistry. I loved art. So we actually synthesized our own pigments, synthesized our own wet lime, and fresco painted, talking about those chemical processes all along the way. Now our paintings, our frescoes, probably weren't masterpieces. But I argue that teacher, that one-of-a-kind teacher, that first grade teacher, I don't want to say her name wrong again, that can really make you care is a masterpiece. Now what does that have to do with the Grand Canyon? Well, I asked you before, and a lot of you are first-timers. And you all came to see this masterpiece behind us. We've got a family from China, lots of Floridians, Philadelphians, Californians, Seattleans, lots and lots of countries and states represented here. And you all came to see this masterpiece. And when I look at this masterpiece, I think about that masterpiece of a teacher. This Grand Canyon has a lot to teach us. In all of these rocks that you see is the story of 1/3 of the Earth's history. Our teacher today, our Grand Canyon, is about 277 river miles long. It's 10 miles across on average. Now 10 miles doesn't sound like such a big number after I threw out two. We could, it'd be really, really big and it'd probably ruin the view. 10 miles across. Not so big after I said 277, but to get to the other rim, it is a 5-hour drive. That's 2 miles an hour. Or a 2 or 3 day hike. Makes it seem a lot bigger. And it's on average 1 mile deep. That's our teacher today, 277 by 10 by 1. Huge teacher. You want to hear his story? How he got here with us today? Yeah. So what is the first thing you have to do to become a teacher? Does anybody have any ideas? It's the first thing you have to do. You want to become a teacher. What do you think? You don't know? Any idea? At school? You really like being at school? That's good. Oh, you don't? Well, maybe you will. The first thing you have to do to become a teacher is go to school. It's learn. That is a California condor, so everyone should look.
Oh, wow.
Yeah.
That is cool.
Very nice. There are about 70 condors in the park and only 400 alive in the world, so you just saw a magnificent sight.
Did you get it?
Beautiful.
Nice.
And that black head means that he's under 6 years old, he or she. So you just saw a young one. So the first thing you have to do to become a canyon or a teacher is go to school. You have to get all that knowledge that you're going to teach your pupils or your visitors. All of the knowledge that the Grand Canyon holds for us today is found in the rocks. And not only the character of the rocks, what they are and how they're made. Very nice.
He's showing off.
He is showing off. You see that straight wingspan? Yeah.
You have to
So that's
send
how you
this
can
to
tell
us.
if it's a condor, not a turkey vulture. Turkey vulture's wings go up past the vertical to form a little V and they kind of teeter.
Let's see this. Let's see this.
So all of that knowledge is found in the rocks of the Grand Canyon. Those rocks, and not only what those rocks are, but what they hold. What color they are, the fossils that are found in them. The Grand Canyon has all three types of rock. There's a metamorphic rock. Do you know any of the other two? No, yeah. It's a little tough question. Igneous rock and sedimentary rock. And the metamorphic and igneous rock is found down at the bottom of the canyon. So we can see two bits of the river from here. That gray, or black and gray and pink rock, those are the metamorphic and igneous rocks. That black is the metamorphic and that pink is igneous. Metamorphic rock is rock that's been altered, it's been morphed by heat, like we all are today, or pressure. And igneous rock is molten lava that's cooled. And if that lava cools on the surface, you get obsidian, volcanic rock. And if it cools inside the earth, like it did here, you get granites. So you've got all that metamorphic rock and those pink streaks of igneous granite going up those rocks.
It
might be a volcano. Might be, it could have been, maybe. Those rocks are 1.8 billion years old. The Earth itself is 4.55. That is a lot of Earth history. And those rocks got here when the North American continent, that plate, that the Earth is made up of several plates. The North American plate that this continent sits on, its formation gave us those rocks. And on top of those rocks, we've got sedimentary rocks. All the rest are sedimentary. That means that they formed from sediment just like what we see today. And over time, as different climates put different sediments on top and on top and on top, layer after layer after layer, that weight pushed out the water and made them rock. And each of those sandstones, mudstones, limestones, tells us another piece of Earth's history. Each different climate that was here over time gave us a layer or took away a layer. It's a really complicated history to make all those shapes and colors that we see out there. That bottom layer of the canyon, the tapeat sandstone just above those almost volcanoes, is a tapeat sandstone. The Grand Canyon used to be a coastline. We had the beach to our west, sand below our feet, and cliffs of those rocks. Used to be a coastline. That's where you get all the sand for that sandstone, but we don't have any life yet. This was 550 million years ago. So we don't have any land. Above that, you see that soft green layer? That's the Bright Angel Shale. And shale is a fancy word for mudstone. It's only 5 letters, so I don't know how fancy it is, but a different word. And that was a shallow ocean, where you get those muds. And all throughout that layer, we find trilobite fossils. That's this creature right here in that picture. Yeah, you see the trilobite? It's an ancient, ancient animal. And my favorite fact, one of my favorite facts about the canyon, is that that green color, it comes from a chemical called glauconite. And glauconite comes from trilobite poop. So we can thank these trilobites for that green color of the canyon. All right, we're going to travel through time a little bit to the top. Those red layers above that cliff, those are the Supai Group and Hermit Shale. The Supai Group is the lower one, and we were a broad coastal plain. Little bits of water, little bits of sand. You get different types of rock, which makes it a group rather than a single type of rock. And that's when we started seeing plants here. And the Hermit Shale above it, this is a tarantula hawk. This big old beetle.
Tarantula hawk.
And the Supai Group, the Hermit Shale was a swamp. Really swampy, get those muds to be a shale, with lots and lots of life, plants and animals now. And this life is what gives us that red color. Your blood is red when it carries oxygen. Life has lots and lots of iron that's in our blood to carry that oxygen. And those rocks are red because there's lots of iron in them bound to oxygen, just like happens in our blood. My favorite layer is the Coconino sandstone, that bathtub ring of the canyon, that white bathtub ring.
I think it's crazy looking.
So we talked about a sandstone already. It was a coastline. But there's another area where you can get sand, and that is a desert. The Grand Canyon used to be a desert on the level of the Sahara. Huge, huge desert giving us all that sand. And in this Coconino sandstone, you can actually find reptile footprints and trackways. Those benches in front of the Bright Angel Shale, they're made out of Coconino sandstone. And if you pick the right seat to sit on, you can sit on reptile trackways. Really, really cool. And the layer that you guys are all sitting on, and you guys are sitting on by proxy, is the Kaibab Limestone. And it was a deeper ocean. You got shark's teeth, horned corals, brachiopods, shell fossils, sponges, lots and lots of great fossils in this limestone, this deep ocean climate that gave us this top layer. And this top layer is 270 million years old. Mind blowing. If you're interested in seeing more of these fossils, there's some fossil beds out at the beginning of that trail that the red bus happens. So if you don't get on that red bus but you walk to the first bus stop, you'll pass some fossil beds and you can go find some. So it's all these different climates that gave the canyon its knowledge, created those different rocks, those different colors, those different layers that give us those colors and shapes, all that knowledge. So if we looked at the Grand Canyon when we had all of that knowledge, we're a big, pretty pile of smart rocks. But we're not quite a canyon yet. We just talked about how that Kaibab limestone was made in an ocean. But are we at sea level today? No. So that's the second step in how this canyon got here. Why is it here? To become a teacher, to me, the second thing you have to do is put yourself in a position to teach. Get that master's degree, find your teaching job, find the school you want to teach at. For the Grand Canyon, putting itself in a position to teach meant getting from 0 feet to 7,000 on this rim and 8,000 to 9,000 on the north rim. 70 million years ago, an event called the Lair Orogeny occurred. Really fancy name. But basically those plates that move around the Earth collided. And usually when they collide, you get mountains. Like the Rocky Mountains just to our east. And those Rocky Mountains were the edge of that collision. It was the North American plate with the ancestor of the Pacific plate. And that edge gave us the Rocky Mountains, but something very special happened. And the exact details are still a little bit in debate. But my favorite geologist, he's also a ranger here, his name is Russell. Many of you have met him at the Visitor Center or for his programs. Says that what's most convincing to him, the argument that's most convincing, is that that rock, that collision happened so fast that it was like a shock to the system. Now fast is geologic time, so it still took millions of years, but a blink of the eye to the age of the Earth. And it moved so fast that those rocks didn't have time to break up. It's like getting burnt and you don't know you just got burnt until later. You end up at 7,000 feet. And we stayed flat. So we're really, really high in the sky, but we stayed flat. And that's really, really important because the next step in becoming a teacher is teaching. You've gotten that education, you've found your job, now you get to teach. You get to start exposing that knowledge to all your visitors, all your pupils, your students. And for that, the Grand Canyon needed a little bit of help. And that help came in the form of the Colorado River. The Colorado River runs from the Rocky Mountains all the way to the Gulf of California. In theory, it usually dries up before it gets there. So 1,400 miles. For every mile that that river travels, it drops 10 feet in elevation. It starts at 14,000 feet and ends at sea level. That gives it a lot of power, a lot of gravity to do something like this. Carve down through that rock. And if we weren't high and flat, that river would have just picked the weakest rock, one of those shales. Mudstones are really easy to break apart. That's why you get those soft banks. It would have picked those shales and made a really narrow, deep canyon. And then we wouldn't be in the Grand Canyon. We would just be a narrow canyon that's really cool. So the reason that we're flat made a huge difference. But that Colorado River has actually never been much wider than it is today. Keep that in mind. The Colorado River is 300 feet wide, about 30 to 40 feet deep, and flows at 30,000 cubic feet per second. Now that's a tricky number to understand. What does that mean, a cubic foot of water per second? Well, if you filled 4 basketballs with water, that would be 1 cubic foot. That means every 1 Mississippi, 120,000 basketballs are passing in front of you full of water. That is a lot of water. And before the dams, we would get seasonal floods. That snow melt in the spring and summer monsoons would flood this river and carry lots and lots of dirt. This is what the river looks like now, that blue, green, clear color thanks to the dams. And this is what it used to look like when it was carrying all that dirt. One of the famous quotes about the canyon is that it was too thick to drink and too thin to plow, full of dirt. Yeah, we made it. And when you had floods, it wasn't just pushing tiny dirt like I have in this bottle. It was pushing boulders. Those floods could be 100,000 cubic feet per second. That's 400,000 basketballs every 1 Mississippi. That is a lot of power. And it would push boulders. And not just boulders, but boulders the size of your house. Not quite planets, but really, really big rocks. And those rocks would slam into the bedrock of that canyon. One of our rangers, Ron, likes to say it's a liquid jackhammer. It's pushing those big rocks and they're just bouncing off the bottom of that canyon, going deeper and deeper and deeper. But it's never been much wider than it has been today. So how do we get this Grand Canyon 10 miles wide? Well, that comes down to the last part of being a teacher. A mile. Where does a teacher teach? They teach in a school. They teach in a classroom. And their environment determines a lot of how they can teach. Just like with a teacher, the environment for this canyon determined its final shape. We're in a desert, so we don't get a lot of precipitation. And why is that important? When you look out at this canyon, what are you seeing? Rocks. Yeah, not a trick question. We are looking at naked rocks. If we had lots and lots of water here, we'd be looking at a really cool, like V-shaped forest. But because we don't have all those plants, we don't have that forest, these rocks are exposed. And that means every time it rains, every time it snows, they don't have any plant roots to hold that dirt there, protect it from the wind. Wind plays a very minuscule part, but it does play a part, mostly rain and snow. When those summer monsoons come, they can pick up that dirt and look like this as they flow down into the sides of the canyon. Flow down to that river. The only time you'll see the Colorado look its natural red color is when there's been a big monsoon and the tributaries that aren't dammed can still give it some dirt. And that's that summer rain washing it in. And in the winter, we get what's called freeze-thaw erosion. Another fancy word, tough to understand. But has anybody ever left a full water bottle in the freezer? Yeah, we've got lots of Floridians. I used to always break our water bottles because I put it in the freezer to keep it cold, but it was full. And I broke it because when water freezes, it expands. That's why icebergs float. And we're in a desert. We're in that classroom, which means we don't hold our temperatures. That's exhibited by today. It was 35 this morning, and the 72 is the high today. That means all the snow that we get can melt. And at night, when it drops back below freezing, that snow can freeze. The melted snow trickles down into all the cracks in these rocks. And at night, when it freezes, that water expands. And it literally pushes rocks over the edge of this canyon. So rain and snow are a huge reason this canyon is so wide, at 10 miles wide. But now, we have a canyon. He's really, really smart. He's got all those rocks from all those different climates over time. He found his teaching position at 7,000 feet elevation. He started exposing his knowledge with the Colorado River, and then that desert environment helped him come to his full glory. But do you want to know my favorite thing about this canyon teacher? My favorite thing about this teacher right behind us is that he's not just mine. And he's not just yours. He is all of ours. We all own him together as a national park. And that means that I don't get to only learn from him. It doesn't talk. But we all get to learn from him together. And because the national park's mission is preservation, we get to enjoy him in the future. And our children can come here and learn that Earth's history he has to tell us, and our children's children can come here to learn this history that he has to tell us. So I want to thank you for being today's visitors to this canyon's education and spending the past 30 minutes here with me. And I want you all to have safe travels as you get back to Florida, California, Seattle, China, Philadelphia, all those places that you guys traveled here from. And Junior Rangers, don't leave without my signature. All right?